Welcome to all. Myself K. Surisha, working as assistant professor in Mechanical Engineering Department in MBR College of Engineering and Technology. Today I would like to teach the subject of thermodynamics to second year, first semester. So already some topics I was completed. I will continue the next topic. The next topic is causes of irreversibility. Already we have discussed about reversibility and irreversibility. Irreversibility, which may not causes any losses of the system. That's why we are getting a 100% efficiency in reversible process. When we consider of about the irreversibility, because of there is a losses occurred in the system like a friction, what are the different types of losses occur that may chance to decreases the efficiency of a system. So all of because it causes of irreversibility. So what are those causes of irreversibility is four of most causes of irreversibility are: one thing is friction. If we consider piston and the cylinder, friction is the most loss. Unrestrained expansion of a fluid. Unrestrained, which means it is not expand freely, so that is unrestrained expansion of a fluid. Heat transfer through finite temperature difference. Okay, mixing of two different substances. So those are all the most causes of irreversibility. These factors are present in real irreversible process and prevent this process from being irreversible. If you can prevent from being reversible. Next, already have told point function, path function. When two properties locate at a point on the graph coordinate axis, then those properties are called as point function. Examples: pressure, temperature, volume, etc. Those properties are exact differential because of we indicate a particular point on the graph, which means dv change in volume is v2 minus v1. If v1 equal to v2, dv is equal to 0. It is exactly differential. When we talk of about the path function, which means we does not indicate a heat and work on the graph because it is not a point function, it is a path function. So there are certain quantities which cannot be located on a graph by a point but are given by the area or so on that graph. In that case, the area of the area on the graph pertaining to particular process is a function of the path of the process. Such quantities are called path functions. Already I have discussed in earlier class. Examples: heat and work, etc. Energy, there are two types: stored energy, which means it is energy possessed by system. It is energy possessed by system within the boundaries. Energy possessed by system within the boundaries. So kinetic energy, potential energy, internal energy. So those are all the energies within in the system, within in the boundaries is stored energy. Transient energy, it is defined as the energy which is capable of crossing the boundary. So which is the capable of crossing the boundaries is known as the transient energy. Which type of energies are crossing the boundaries are heat and work. Heat, it can cross the boundary, and work can cross the boundary. And next, heat. What is heat? Heat is that form of energy which transformed one body to another on account of temperature difference. So, on account of temperature difference, okay, temperature difference, it transforms one body to another. Okay, for example, one iron rod. We have take one iron rod and heated on one side. Temperature is initially 300 degrees centigrade. After some time we place another side, we feel some heat. After some time we feel some heat because of temperature difference. Initially it is 300 degrees centigrade. After some time it decreases temperature to 150 degrees centigrade. So it passes, it flows through the heat flows from one end to another with the help of we take the law of conduction. So temperature difference takes place. It is a form of energy which is transferred from one body to another on the account of temperature difference. And next, work is a transient form of energy. because it crosses the boundary. When a force acts upon your body, causing the body to move and to overcome continually resistance, so work is said to be done. Difference between heat and work. It occurs due to temperature difference. Work, it caused due to displacement or motion. So already I have taken example of iron rod. So in a work, you want to move the block. You want to move the block. How it moves? So initially block it one place. So how to move? What it happens? It moves at some distance. So it caused due to displacement or motion by applying some work only. Okay, it is low grade energy, it is high grade. Why it is low grade energy? Why it is high grade energy? So it is low grade energy because if you give 350 kilojoules of heat to a system. Okay, consider piston and cylinder. If you give the 350 kilojoule of heat to the system, it is running. After some time, 350 is into it is into 150 degrees centigrade. Because of it is continuously running, it loses it loses some energy because of some friction, whatever. Not heat, we give some amount of work. After we take some piston and cylinder, it is doing some work. Actually want to get 400 kilojoule of heat, but due to some losses in the piston and cylinder, like piston friction, some bearing losses, so those are all considered. It has some losses. So due to some losses, we want 400 kilojoules, but because of some losses we get only 350 kilojoules. So we did not get the 100% of energy, heat energy. So that is why it is a low grade energy. And why it is high grade energy? Why it is high grade energy? We ate we ate we Actually, I ate one apple. It is 200 kilo. It is 200 kilojoules. I have some energy. We want to apply some block. We put more effect and complete energy converted into work. We can convert. We convert complete energy into work. So that way, we do not complete energy into work in heat. We can complete energy into work is known as a work. In stable condition, there is no restriction for heat transfer. In stable condition, there is no work transfer. So if in stable condition also, if for example iron rod, if it is in stable condition also, it can transfer heat from one body to another body. It can, but in stable condition there is no work. If one rod is there, we fix that rod. Can you do the work by fixed rod? No. So in stable condition there is no work transfer. So in heat it is denoted by Q. In work it is denoted by W. This question is very important in the exam point of view. Enthalpy. What is enthalpy? What is enthalpy? It is a total heat content of the system and defined as energy, which is algebraic sum of internal energy and flow work. It is the algebraic sum of internal energy and flow work. So H is equal to internal energy plus flow work is P into V. P into V. So where H is equal to total enthalpy, U is internal energy, P is absolute pressure, V is a volume. So heat and enthalpy is the algebraic sum of internal energy and flow work of the system. Entropy. What is entropy? So I will explain entropy briefly. So listen carefully. What is entropy? So entropy, suppose boiler is the water molecules, and after when some amount of heat is given to the water, after some time what the boiler do, it change the phase transformation water into steam. In steam we are having number of molecules. When we give a large amount of heat given to the molecules, it motion randomly. So when we are having high amount of random motion particles, molecules is nothing but high entropy. If we have, if we consider to the liquid, it have less random motion of molecules, so it is less entropy. So finally, what is entropy? Random motion of molecules is nothing but entropy. It means transformation. Entropy is a thermodynamic property of a working substance which increases with the addition of heat and decreases with removal of heat. Entropy is represented by S or phi. change in entropy dq by T. dq by T. T is absolute temperature, dq is equal to change in heat, and delta S is delta is a change in entropy. Unit of entropy kilojoule per kg Kelvin. Next, laws of thermodynamics. In laws of thermodynamics, actually we have zeroth law, first law, second law, and third law. But in this first unit, we know only zeroth law of thermodynamics. What is zeroth law of thermodynamics? In zeroth law of thermodynamics, especially it tells what is the temperature measurement. Okay, so in zeroth law of thermodynamics, we have three systems. We have three systems here. Actually, if two systems are if two systems are each is thermal equilibrium with the third system, when two systems are also in thermal equilibrium with one another, actually one system is there, that is system C. Okay, when two bodies are considered, we are taking C with A. Two are thermal. If C is 50 degrees centigrade, so the system C is contact with system A, it is thermal equilibrium. When system C is contact with system B, it is also in thermal equilibrium. So if two systems are each is thermal equilibrium when with a third system, then the two systems are also in thermal equilibrium with each other. So system C with A is thermal equilibrium. System C with system B is in thermal equilibrium. So system A and B are also in thermal equilibrium. So that is the zeroth law of thermodynamics. If system A and system C and system B, if system A and system C and system B and system C are thermal equilibrium with each other, then system A and B are also in thermal equilibrium with each other. Okay, concept of temperature. What is concept of temperature? The zeroth law of thermodynamics defines thermal equilibrium. Okay, the zeroth law of thermodynamics, what it says, it defines thermal equilibrium and forms a basis for the definition of temperature. If two systems are in each thermal equilibrium with the third system, then are in thermal equilibrium with each other, which means system C is there. Okay, now two systems are taken. System A with system C is thermal equilibrium, so both are 50 degrees centigrade. System B with system C with system B, both are in equilibrium. So system A and system B are also in, both are in equilibrium. So zeroth law says that the thermal equilibrium with each other. Okay. So that is the concept of temperature taken from the zeroth law of thermodynamics. What is thermometry? Thermometry is nothing but branch of heat relating to the measurement of temperature of a body is called thermometry. So measurement of temperature of a body is called thermometry. Types of thermometers is nothing but liquid thermometer based on principle of change in volume of liquid with the change in temperature. Change in liquid with change in temperature. Examples: mercury and alcohol thermometer. Gas thermometer based on principle of changes in pressure or volume with change in temperature. So gases. So example: constant volume hydrogen thermometer. Next, thermoelectric thermometers based on the principle of thermoelectricity. Examples: platinum and rhodium. So the final topic in first unit is constant volume gas thermometer. It is the bath or environment to be measured, flexible hose, mercury reservoir, and this is the scale, and this is the height to be measured. Okay, this is the pressure, gas pressure. So we are taking this volume of is constant. This volume is rising up and down. So the rising up and down of liquid, it can be calculated. Okay, it can be calculated. So the physical property used in this device is pressure variation with the temperature, variation with the temperature of a fixed volume gas. Volume is fixed. Okay, here volume is fixed and temperature changes. Temperature changes with the pressure variation. The volume of the gas in the flask, the volume of the glass in the flask is kept constant by raising or lowering the reservoir B. This volume is kept constant. The volume of reservoir B is raising or lowering to keep the mercury at level A at constant. By using these variations, we can calculate the temperature. So pressure variations. By varying the variations of pressure, we can calculate the temperatures. Thank you, students. I hope understand.